Hi everyone, myself Amar. I am currently pursuing MSc Physics from IIT Jodhpur. So today we are going to discuss about most fascinating topic, that is total internal reflection. So total internal reflection is a property of light. When we study light in detail, then one of the property of light is called total internal reflection. So before I am going to discuss about total internal reflection, get some idea about what is light, how light behaves. So in physics, when we study about light, then we consider two properties of light. Means the main thing is light have dual nature. One is wave nature, second one is particle nature. Okay, so light has dual nature. First thing is wave nature. In considering light have wave nature, we discuss topic like reflection, refraction, interference, diffraction. All these things we can explain and analyze by considering the property of light as a wave. Okay. So when we consider light as a particle, so particle means that like you consider a chips or something, that it has particle, it has some mass, it has some energy. So considering light as a particle, we can explain the topic like photoelectric effect, Compton effect, and another things are there also. But today our main focus is on refraction and total internal reflection, because to discuss about total internal reflection I need to discuss about refraction. So let's deep dive into the physics of light through refraction. Okay, so student, let's consider here that this is a material. This is a something substance which has some property like in physics, in the light physics, we consider light has a wave, and after that when light is falling on a substance, when light is falling on the surface of a substance, then two things may happen. One thing is light may reflect back from the surface, or second thing is light may refract back. Refract means it is going inside to that material. Okay, so one property is reflection and second one is refraction. So now let's discuss about focus here. This is a material you have taken. Let's take it is a glass. Okay, glass. Now this is the normal to the surface of the material. Okay. Now a light is incidenting on the surface of that material, and it is going inside that material like this. So how we can analyze that, how light is behaving when it is going inside that material? Some properties are changing of light. Means you have seen that when you are sending a light into a transparent bottle, then the direction of light changes. So why changes? How it changes? So all these things we can explain through this refraction process. So scientist Snell has given a law that how light will behave when it goes inside a material. So Snell's law tells that n1 sine theta 1 is equal to n2 sine theta 2. So let's consider this environment, means air, where has refractive index n1. Okay, refractive index n1, and that material have refractive index n2. Okay, and with the normal it is making an angle theta. When I am sending light, I am making an angle theta with the normal, that is I am calling theta 1, and when it passing through that material, it is making angle theta 2 with the normal. So n1 sin theta 1 is equal to n2 sin theta 2. This is our first concept. Just remember it. That n1, the refractive index of the first medium, and angle it is making with the normal. So n1 sin theta 1 equal to n2 sin theta 2. Don't do any mistake. Students are doing that, they forgot that n1 is for which medium, n2 is for which medium, theta with n1 is for which medium. So n1 for the first medium, theta is also for the first medium. So first we discussed refraction. Now we are going to discuss about total internal reflection. Same thing I am considering. This is a surface. Okay. So what total internal reflection says? Total internal reflection says when a light is traveling from a denser medium to a rarer medium. Two things, denser and rarer. In the light physics, we define a material with their refractive index. If refractive index is higher, then we call it denser medium. If refractive index is lower, then we call it a lower refractive index material. So I am considering a material which has higher refractive index N1 and a lower refractive index. Consider it air and it is a glass. So glass has more refractive index and air has less refractive index. So when light travels from a denser medium, okay, to a rarer medium, this is angle theta I, theta 1, consider theta 1, and this is angle theta 2. Always angle is with respect to the normal. So for a particular angle of incidence, what I am doing here is that I am increasing the angle of incidence. First I am sending light here with this angle. So Snell's law will tell n1 sin theta 1 is equal to n2 sin theta 2. Okay, this is the thing. Now I will increase my angle to this large value. This is my new theta 1, theta 1 new. Okay, so accordingly my theta 2 will be changed. This will be my new theta 2. Okay, similarly I am now increase to a larger value. Okay, let's erase it and discuss. Now for a particular value of incidence I am increasing, and now I am at a theta 1 new. For a larger value, what I will see that my theta 2, originally that is theta 2, which is making an angle theta 2 with normal. Now it will be 90 degree, means my refracted ray will be parallel to my surface or perpendicular to my normal. So how much angle it will form? It will form 90 degree to the normal, not 0 degree. I am always here angle is with respect to normal, just remember this point. So it is making an angle 90 degree. So in this equation what I can write, n1 sin theta 1 equal to n2 sin 90 degree. What is the value of 90 sin 90? It is 1. So my equation I am just writing here, just focus here, n1 sin theta 1 equal to n2 sin 90. Okay, next n1 sin theta 1 equal to n2 into 1. Now n1 sin theta 1 is equal to n2, means I can write sin theta 1 is equal to n2 by n1. n2 means the medium, rarer medium. n1 means denser medium, where fast medium, from where I am sending my light. Okay, so this angle, for which angle the refracted ray will go with respect to the normal with a angle of 90 degree, then we call it theta 1, which is, we call it critical angle of the surface. So second concept is critical angle. What is critical angle? When we send a light at a particular angle, it is called critical angle of the surface. And critical angle explain that after, if I send light with a larger than my critical angle, then light will reflect back to my surface. Now I am sending my light with a larger value than a critical angle. Okay, थीटा न्यू मेरा क्या हो जाएगा, थीटा सी जो ये था इससे बड़ा हो जाएगा. जब बड़ा होगा तो क्या होगा, लाइट विल रिफ्लेक्ट बैक टू माय सरफेस. Now my light is traveling through this and going into my surface. It is not refracting back to the another medium. It is going reflecting back to my same medium. So here total internal reflection. It is doing reflection and going to the going inside to the surface. So this is the whole concept. So let's focus on the example. Let's see here that this is a glass plate. Okay, here I am sending a light to the surface AB, okay, at angle 30 degree with this normal. So now my normal is this. Okay, my angle is 30 degree. Now when light will enter inside that material, obviously it will do refraction. So after refraction, it is pointing at point D. So here the question is, you have to tell if their total internal reflection will occur or not. So only we have to given the refractive index of the material is √2, okay, and the outer means air has refractive index 1, and the angle is 30 degree at which I am incidenting my light. So to solve this, we have to remember these three concepts, and periodically we have to apply these three concepts. First concept. So my light is going from one medium to another medium. So first Snell's law will be applied. That Snell's law what tells? N1 sin theta 1 is equal to N2 sin theta 2. Okay. Here my for the air I am considering this medium. Okay. First consider about that N1 medium, means inside medium. N1 has refractive index √2 sin theta 1 हमें पता नहीं है, equal to N2 outer medium which have refractive index 1 sin theta 2. Here I am sending light with angle theta is equal to 30 degree. So I will use theta is equal to 30 degree here. Okay. Now what I will do, that √2 sin theta 1 equal to 1 into sin 30 is equal to 1 by 2. Okay. Now my sin theta 1 equal to 1 by 2 √2. Okay. My sin theta 1 is equal to 1 by 2 √2. Now I have to find that what is my theta 1. Okay. What is theta 1? Light is sending from this. Now for me this is theta 1, angle to the normal to the surface. Now my surface is like this, perpendicular, and this is the normal to my surface AB. Okay. So if incident theta is this, then the refracted theta will be this. I am considering theta 1 equal to this. So my theta 1 is equal to sin inverse 1 by 2 √2. Okay. This is theta 1. So what is the value of theta 1? Theta 1 equal to 20.70 degree. It will be given to you in the question that what is the value of sin inverse 1 by 2 √2. So now I got my value of theta 1 is equal to 20.70 degree. So I am writing here that 20.70 degree. Okay. 20.70 degree. Okay. Now for me to occur total internal reflection, my angle of incidence should be lower than what? The critical value. Now I will assuming that all the concepts are given. So what is critical angle? Sin theta c is equal to sin inverse n2 by n1. Okay, n2 by n1. So me sin inverse n2 क्या? n2 is the outer medium. So 1 by √2. So sin inverse 1 by √2. What is it? What is its value? It is 45 degree. So if my angle of incidence will be greater than 45 degree, means it is now for me this is the normal, because there is a difference in the medium and light is falling on this surface. Okay. So this angle should be greater than 45 degree. Okay. How we will find this angle? For finding this angle, I know this is 90 degree. So my angle theta will be 90 minus 20.70 degree. So it will be 69.30 degree. Okay. Understood? So first we have used the concept Snell's law. From Snell's law we find this angle theta 1, and now light will incident on the surface and it will do refraction or total internal reflection. It will depend on the angle of incidence. For me now this will be my angle of incidence theta. So I am finding theta. How we will find theta? Because we found theta 1 from Snell's law. 90 minus theta will be my angle of incidence. Now my angle is 69 degree, but critical angle is 45 degree. So it is greater than critical angle. So total internal reflection will occur. So that's this is a problem. So basically this concept used in optical fiber. So